So I see concrete has a hard standing, and that causes also will raise some questions. Maybe we stick to that. Take a seat. Maybe we stick to that with you at Leipziger Baader and also the prize you won. How is an industry supporting you with your Hochschulpreis and what you developed? Are you developing it there further, or?
Well, in the context specifically of that project, we're now, I think we can say it at this point, we're now fortunate enough to having acquired research money. So we're actually developing that in a broader research project. I hope I didn't say that too early.
Is your the founder here or someone represent?
Catherine, obviously, with whom I did this thesis back then. And Leipziger Baader is an industry partner in this project, among others. And obviously there we're developing it further. In other things, for example, like those cavity bricks, I mean, in an industry company, it's as simple as, you know, just go to the workshop, and if you need people, you get people, and just do it. That's as simple as it is. And at Leipziger Baader, we're a very pragmatic company. We try to keep bureaucracy extremely slim. And for example, in case of these projects, we have meetings sometimes, and we discuss on the progress, but at the end of the day, it's me just walking into the workshop and being like, I have to do this, I have to do that, I have to do that, I have to do that. And slowly and steadily getting it in the construction industry. And it's not hard to convince, for example, clients and architects to implement this then.
Okay, interesting. So I then take it to our startups here. Maybe you do a startup or a spin out then from Leipziger Baader. If you don't have this environment or a workshop there, or you need to build a workshop first then to produce that, what's your struggle? Or you have been already through that for the 8-9 years? If you see the startups, the new things coming, what are your biggest struggles, challenges?
Yeah, I think in general, if you would like to automate construction industry, you need a lot of hardware, and hardware is expensive. And I think this is one of the main challenges in a construction automation. Plus that every construction site is very different, right? It's if you go to medical industry inside the hospitals, everything can be predictable. You can put a robot moving on a floor. Same with logistics industry, right? Same with the car production industry. And on construction site is nothing like that. So a lot of the talks when we started from the industry were that you guys will never be able to certify a machine which is moving with 500 kilograms on such a speed. We move with 42 minutes per minute, uncontrollable. And indeed, it took us 2 years just to certify the system, so to design and to certify. And I think here, for us, it was crucial that we actually had a support of TUM and Unternehmer TUM as well, because we had the space, and then we had makerspace, and this is where the first robots were done. They were all done in makerspace. And then next thing, I think it's good industry partners, because we found partners in Germany who were willing to produce prototypes for us, and it's really hard to convince people to produce just a single prototype. So I think this is a struggle for the construction automation. You just need right amount of capital, and if you're starting as a startup, you also need a space to work and to create these prototypes. But if you're coming from a bigger company, I guess you can have all of that because you have people and you have resources. So the only thing you need to be careful about is time and how to manage these resources.
So we don't have like resources just like that.
Yeah,
I mean we can't.
Julian, I would just take it over then, because for industry corporations, Thomas, would that be something, not with Skanska, an established company, also to work with startups, or with Leipziger Baader, a smaller one, or to provide the space? By the way, we as TUM Venture Lab also provide spaces and facilities through our professorships. So in that, we are also capable to foster, but industry partners would be a bit more potent.
Yeah, for sure. So, and the direct answer to your question is, okay, as a startup, you might have the challenge, that you need to start small by the given boundary conditions you have. we have the problems that we usually start big, and we start too big. So, and again, this is a learning, though, that all this discussion on minimal viable products, so that we really need, so if you really would like to bring innovation into the market, you need to be fast, and you need to make sure that you make the right decisions in a very short time frame. So, you are allowed to make mistakes, but make sure you fail fast. And this is something, I guess, the big companies started to learn from the startup culture, and that's why we are collaborating also with startups as well. We see that innovation is needed and possible between startups, but also, as you can see here, together with other companies. So it is as well as everybody might agree that there is a strong need for automation and in bringing robotics and everything in the construction industry. We are automation guys. We know robotics, but we don't know the construction industry. But a partner like Skanska knows the construction industry. And I strongly believe that it is that we will succeed if we bring the right people together, working together, setting up structures to making the right decisions fast enough to follow the market.
How far are you, Anna, from collaborating with a company like ABB or an industry partner?
So, because we come from the research environment, we had extensive collaboration with large companies, among which also ABB. All the robots we are using in printing, for instance, are ABB robots, and we see a lot of value in the support from industry in developing new ideas. But what I wanted to say is that this is maybe not enough to push forward new ideas. I think it is also part of finding new clients and people that are willing to take up the risk of developing new systems and new architectures. And I want to give the example of the two collaborations we had with the practice. In both cases, we worked with either architects or clients, cultural foundations, to push forward ideas that take advantage of these novel developments to produce new kinds of architectures, new kinds of designs that go beyond simple optimization. So I think this is very important in pushing.
So also architects or architectural officers should focus on your solutions to work with, right?
Yes, I think it is important to engage every player to advance new ideas.
Okay. Ronaldo, on your side, you agree with Anna, or you already said, I mean, the slabs you showed, they can be transported already.
Yeah. I mean, we are producing them. We are active company since this January. I agree basically with everyone in this panel, from Julian saying that we need to reintroduce some mass and to not forget that we have other requirements that we need to take care of. With Anna and Ekaterina saying that we need to involve stakeholders, but also regulations. I mean, in structural engineering, probably yesterday, Professor Jan Smit, I think it was his name, he was actually saying that, that you are responsible for your structures, and you can go to jail for it. And so there is a lot of people are trying to not to innovate too much and to do everything in very little steps, and this is probably the biggest challenge to.
I'm coming to one thing you said, maybe unreinforced concrete is the future. How far is it, or we can then challenge the robot you developed then if the welding is not needed anymore. So how strong is your belief, or what needs to be done to go to that direction?
Look, I'm not saying that we don't need reinforcement in every structure that we do, but there are certain ways of placing materials. So what we do right now, we use concrete in the way that it does not want to be used. What we should do is use concrete as a synthetic stone. Anna was showing a plot of the embodied emissions of concrete and so on, and you will see two things. One is that the embodied carbon, embodied emission, embodied energy is very low, and another thing is that it's even lower when you use low cement. And so you can do this when you actually you place material where it needs to be, what we call strength through geometry. You don't over-engineer your materials. Now, for floors, this is possible. We showed it through 10 years of research and now in real life. And of course, what you need to do to make it really happening is to convince regulators. And so normally, people get scared just because it's a curved thing and it's not a standard flat slab. But you can use exactly the same building codes, to prove that they work totally fine. And also you resolve many other problems. For example, for fire safety, you don't need anymore the cover because you don't need the reinforcement inside. And for assembly, you don't need to do external operation on site because you don't need to bond the reinforcement, and so on and so on and so on. So I think we evolved in a place where we are trying to fix the problem of rebars, but we can actually just remove them.
And then use earth, for example, or try to make a slab like that possible.
Exactly. But
but we need some more. We need some more disagreement, or we need to spice up the discussion a bit, right? If there is someone in the audience who wants to raise a critical question, please feel free. We have some microphones around to jump into the discussion. Thomas, you wanted to say something?
But it was also in kind of agreeing. I guess what is shown here, that software, that programs are a key resource to come to this to come to innovative solutions, isn't it? So you mentioned it, though there might be new ways of designing concrete slabs that are driven by design and by data and by these tools and by software. For us, it's the same for robotics. As you said, robotics are designed by heart to work in structured environment, even if a car factory does not look like this. It's super structured. And construction industry is the complete opposite. It's not. But there are new developments, there's new software, there's machine learning, vision based on machine learning that really enables this one. So I guess we share, sorry for not being controversial, but we share again a common denominator in having being data-driven, being software-driven, and this can help to transform the industry.
Maybe I challenge then something here, because you're doing building materials or components for buildings, but what is the next step then as a startup to continue? You slightly touched it. I would direct that to your question. You can survey the whole site. I mean, there could be something behind. You may also go into that you're not only a construction assembling company. Maybe you can
develop on it. So basically we have a broader vision, and the vision is to automate construction material delivery and installation. What does it mean? That ideally in the future we would like to automate everything from the point from unloading of the truck to the point of installation on a facade. Now, it is difficult because it contains horizontal and vertical automation, and horizontal automation, as you know, on construction site is also very difficult because every ground is very chaotic, right? And also vertical automation, it could be done in multiple. So right now we are doing only vertical, but the patterns that we have is in vertical, horizontal, diagonal. So there are multiple automation patterns that we can still bring, but in each of the steps has to be sort of like splitted in smaller steps, and this is what we do, because otherwise as a startup you cannot survive. So you need to find a niche, you need to focus on a niche, and then out of the niche you're building, you're scaling, you're addressing further industries, further applications, further automation cases, and then simultaneously you collect data, and this data is not only for your customers, it's also for you. Because then you know where your system works better, how to place the system on a construction site, and you can also predict the outcome based on the previous projects. And this is exactly where we would like to go. But without hardware, you cannot generate this data, and without useful hardware, you cannot convince customers to use it. So it should be very practical, very useful, and with a very concrete application in our view as Kevazo.
Great. Is there a question?
Yes, thank you very much for the presentation. I would like to maybe challenge a little bit the title of the panel, Getting New Things Done, and ask, what about taking care of what we already have? And where do all these innovations come in when we look at that question?
I would direct it directly to start with Julian and his last slide.
Would you mind repeating it? I didn't understand acoustically. What was the first sentence? What?
I wanted to challenge Getting New Things Done,
yes,
which is the title of the panel, and
yes,
ask about what about taking care of what we already have?
I mean,
like
that's a very broad question.
Existing buildings, existing structures, maintenance, refurbishment, all these things.
I mean, again, seeing it from a company perspective, I would say that's where like our dry boards and our plaster comes in, but it's kind of a cheap answer, because at the end of the day, it's a very architectural question, actually, how you take care of the stock that you actually have. For example, at the moment, I'm always a bit concerned, for example, about Studentenstadt. That always divides me. There's like, for those who don't know, it's like one of those 50s to 70s student housings, which look kind of dystopic and have crazy suicide rates. And now also some deaths because of a fire that was kind of unnecessary. And it always divided between, from an ecological perspective, you should keep those buildings because you shouldn't tear down those buildings and build from scratch after 40, 50 years. But on the other hand, having been there and having experienced it, having talked to people who live there, it's a question like, how can you ask anyone at the moment to live there? And the question is like, can you transform it to a way it's a nice place? And that's where architects come in. But we also have to be a little bit honest to ourselves and like what we can do and what we cannot do. So you should give it a try, but sometimes you might end up like at Notre Dame, that you have a competition with 200 entries. And at the end of the day, you're like, okay, let's throw them away. Let's just do it the way it was before.
But I also pointed at Julian to answer this question because he is the one proposing for Earth to use some material which has already some embodied energy, which is not as much to producing something new, and then to exchange materials we need to newly produce or to scientifically or to synthetically produce and then to use that, but also with Ronaldo with not reinforcement, which then will be for demolition better to keep that cycle up. But basically it's the question from the moratorium to not build at all in this field. What does an industry player like ABB
Please allow
say?
me to turn the question upside down to make it an answer. So I understood, just to make it make sure. You talk about renovation, maintenance. We have a lot of buildings, and we need to do something to maintain them. Am I right with this one? That's what's your intention?
Instead of building new,
exactly. Yeah.
Taking care of what we already have, which we don't do.
Yeah. I guess I have a pretty easy standpoint or a pretty easy position here, because if you would like to help maintenance and renovation with automation, you have to invent a lot of things new, because it's absolutely not what we are used to do right now. So we are used to do things that are repetitive, high volume, like you need for building new things. But to help you to maintain existing buildings, you need to be very flexible. You have to adapt to structures or to buildings that are not in the CAD data. They are completely, they are variations and everything. And to make automation accessible for this one, you need a lot of software, a lot of new inventions. And for example, the best example that you can also find as a use case and a proof of concept is designing facades for existing buildings that can be very individual, that can be really tailored to existing buildings. Here, I guess robotics and automation in robotics can play an impressive role.
I just wanted to say that this is exactly what we do. We do maintenance of facades, we do maintenance of churches, towers, everything, but we are coming from the perspective of scaffold, right? Because scaffolding is essentially needed. It's a supportive structure to do other work, to do maintenance work. And this is where we are. We don't focus on new buildings at all, because they're built usually layer by layer, and it's not interesting for us. And we also need some sort of a scale. And that's what we do. We do it for construction industry. We also do the same thing in industrial industry. So, for example, you have a BASF plant, and then you have to maintain certain part of BASF. So what's happening, they close, for example, a tank, and then we are going inside the tank with a robot or outside, and then the whole work is done. But this is only one piece. So this is only, I would say, scaffolding piece. Now, how to automate also maybe further works, this would be a challenging question.
From my perspective, as we are between disciplines, also it's also a process and management operation topic, how to reuse things. It's not always a constructing topic, but also to provide a concept for revitalizing spaces and reusing and the concepts. So it's an operation topic as well. It's not strictly done with construction and the construction companies, but also with other disciplines and other parts to develop new use cases then for existing structures. And we see it right now with the opening of the Galeria Kaufhof, I think, the past weekend, where the whole inner city warehouse was rethought and not demolished in the first place. Harald?
Maybe a question to Anna. So I like to know a little bit more about how do you see your business case, so where to integrate for. And I see Ekaterina, then it's clear. So this is automation. So she touches really the existing and makes it better. But you offer, let's say, a totally new technology with new possibilities for shapes. So what is your idea? Do you get a construction company, or what is where you want to step in?
So this is an excellent question. We are looking exactly what are the ways in which we can either focus on a design-driven approach in which we conceive designs that are highly informed by fabrication methods, and also have the tools to fabricate them. So it is a construction company in the end, but it works with automated design pipelines and also automated prefabrication pipelines. We believe a lot in prefabrication as a way to control the quality of the parts we produce, and as a way to ease the assembly on site. But of course, in the case of these technologies, prefabrication is not always possible. So we still have to streamline some aspects that should happen on the construction site, like casting limited amounts of concrete to reinforce or to connect the pieces in a monolithic structure.
And the connection to the material is also you develop your own material, or it's intended, or you take the customized, or?
So the material is very important in these scenarios. We have developed as part of the collaborative research a material that we currently work with. However, it is also something in continuous development. We hope to be able to work with concretes that have lower cement contents, but this is also part of the larger collaboration. We would like to use material that are already developed and available on the market.
Is there any other question from the audience?
One? Hello? Yeah. To Julian. Very inspiring what you also rediscover the past using a mundane material. So maybe also a provocative question to you. So what if we run out of earth? Like if we continue building the way we used to design, especially. But I also saw in your thesis some new approaches of how to design a slab. So you talked about material efficiency through the timber elements and so on. How important is this way of rethinking the way you design earth-based building elements for you in practice?
Well, I mean, to answer like the first question, it's highly unlikely that we're gonna run out of Earth unless we take it to some other planet and some other planets and start building up. We have vast resources of it, and the point is you can always reuse it. You can take these earth components, you have to shred it a little bit, and then you add water, you mix it, and you reuse it. And you can do that for as long as you want. And that's the good news. When it comes to material efficiency, what hurts us rather is like the efficiency in terms of like timber, because timber is expensive material, similar to steel. So when you, for example, you design a floor slab, that's going to be your main cost driver, no matter what. And that's why, for example, those timber concrete compound floor slabs became quite popular, because you can save a little bit of timber by doing that. The earth itself, it actually really doesn't matter. I mean, the expensive part is the fuss all around, get the machinery and everything, because obviously no one's prepared for it at the moment. But once you have the machinery, whether you produce 50 cubic meters or whether you produce 500, doesn't matter anymore.
So thank you for that answer. I would take now the final question, a short answer from all of you. So if you position a university or the TUM then, what should we do in the future? What should universities foster more? Ekaterina.
That's a good question, I think. I mean, I guess it depends on the faculty also you study, and I did technology and innovation management, so we had a lot of focus on the consumer goods, or how to innovate in a consumer space, which is not something what we do right now. So I think if we could encourage innovation really in the industrial sector, this is one. And second, I think that TUM is already doing a lot of things. And when we started, this building did not exist. And I think it's great that you're doing it. Makerspace in a city center, it's also great. It's all of the small things which help startups initially. But most of all, I think it's a thinking. It's a thinking that if you do a startup, it's okay. You're going to fail at some point maybe, but it's fine. And I guess this is from a university point of view. Yeah, from society point of view, we definitely
you already
need more
mentioned 3
capital.
points.
Yeah,
the capital, yes.
Yes, more capital.
For me, universities should be allowed to think brave, to challenge things, and be open to discuss and questioning us as industry and help us to develop new things. But be brave, think new things. Nobody thought before.
We keep doing that. Anna.
For me, it would be interdisciplinary collaboration. In general, the scale of the problems we are confronted with do not belong to one discipline, and I think if we start from an early age to think and to share knowledge, we would get to our goal faster.
Great point as well. Ronaldo?
Well, all the above, and maybe I will answer with Richard Feynman. I put this quote in my PhD, so I know it. He said, "For technology to succeed, all PR must stop, and for nature cannot be fooled." So we should actually really focus on basic science, basic research, and foster from numbers real innovation.
I think for me, it's just this openness to failure. Like when I think back of like my university time, that last project, which was like the floor slabs, no one really thought it would actually work out. Like it was this kind of project where you do and you're like, 90% probability it's just going to be not working out. It's just going to crack up and everything falls down, for example, in this case. But it's university. So, you do your thesis, and if you find out that this does not work out, it's also fine. And I think this is the kind of thinking that we have to push further. And like I also was teaching at university for a short time, and students were always so afraid of like, oh my God, what if this doesn't work at the end? And I'd always be like, yeah, then it didn't work. It's also a nice thing to find out. And often they would retrieve to positions where you just do something where you anyways know it's going to work out, but then you didn't do any innovation at the end of the day because you knew it before. And we just have to foster that and make people aware of that and give them the opportunity to fail.
Thank you very much. That's a bit of a counterintuitive thing if you think of a university to be open, but also students need to be educated or empowered to make failures in new directions. Thank you very much for this interesting panel. Thank you very much in the audience for your... Yeah. Super.